So when you ask a large language model to do something that needs to be perfect, I'm talking complex math, or say writing a legal document that has to hit 10 very specific verifiable points, how do you actually know you can trust the result?
That is the million-dollar question. And that trust, it really all comes down to the judge.
The judge.
Yeah, the LLM judge. These are the absolute bedrock of the whole ecosystem. They're the ones scoring and ranking all the model outputs for quality, for safety, alignment, you name it.
And if the judge is flawed,
Then every single version of the LLM that's trained using that judge, well, it inherits all of those flaws. And right now, the biggest flaw they face is what you might call computational hallucination.
Okay, let's unpack that. This core limitation. So traditional LLM judges, they operate just on the text itself, right?
Yeah.
Purely intrinsic textual reasoning.
Exactly. They are experts at sounding convincing. I mean, they're fantastic at style and tone.
Okay,
But
yeah.
if you ask them to verify something concrete, like, is this entire letter in all caps? Or did the response use the letter O exactly 40 times? That's where their text-based thinking often just, it collapses into a guess, an estimation, or a completely hallucinated count.
Because that kind of textual reasoning is inherently soft when it's facing hard facts.
It is. And we've seen researchers try to fix this, by having the judge output these long chains of thought. But even the most detailed thought process is still trapped. It's limited by the model's inability to do perfect, error-free math or symbolic checks.
And that brings us to the breakthrough we're diving into today, the TIR judge.
The tool integrated reinforcement learning judge.
And this isn't just about, giving the judge a calculator. It's about fundamentally rewriting its DNA through reinforcement learning to teach it how, and maybe more importantly, when, to use a precise tool.
Specifically, a Python code executor to go and verify its own decisions with objective, hard evidence.
So our mission in this deep dive is to really explore how this framework lets these LLM judges self-improve, how they integrate code execution so tightly into the training loop that they get these dramatic accuracy gains.
To the point where they can match or even, in some cases, exceed the performance of much, much larger state-of-the-art text-only models. This is about transforming the judge from a confident guesser into a verifiable fact-checker.
So let's get into this agentic shift in how the judge works. Tool Integrated Reasoning, or TIR. You're saying this moves the judge beyond just thinking, writing out its reasoning, to actually acting.
Yes, exactly. And that action is generating and executing code.
It's like introducing an objective loop into the whole process.
Right. The judgment is no longer just a straight line from prompt to a final score. Now, the trajectory, it involves 3 steps that are all interleaved.
Okay.
You have the natural language thought process, the reasoning. That's followed by the generated Python code. And then finally, you get the objective execution results straight from that external Python interpreter.
Ah, okay. So instead of a text-only judge trying to do math in its head, which we know is error-prone, the TIR judge reasons, okay, this task needs me to verify the result. It then just writes a little piece of code, sends it off to the interpreter, and gets back the undeniable correct answer.
And that output becomes the irrefutable evidence that drives its final judgment.
It closes the loop.
It closes the loop. That tight coupling is what really sets TIR Judge apart. I mean, previous attempts at tool integration, they were usually just simple prompting. You'd tell a finished model, hey, use a tool. Or you'd apply it to these very, very narrow domains.
But this is different.
Very different. By optimizing the code generation and the tool use directly during the reinforcement learning training, the model learns this deep internal policy about when it needs verification, how to write bug-free code to get it, and then crucially, how to weave that verifiable result back into its final conclusion.
It sounds like they're building a judge that's actively trying to disprove its own assumptions. It's using a mathematically perfect tool to do it.
That's a fantastic way to put it. It's a mechanism for eliminating, well, for AIs, it's computational error, which is sort of the equivalent of cognitive bias in these very precise domains.
So to build a judge that can do this, that can switch between verifiable tasks and non-verifiable ones, the researchers focused on 3 key design principles. What are those foundations that make this TIR judge so robust?
Okay, so the first principle is task diversity. This is huge. The judge needs a really sophisticated internal sense of when to call on the code tool.
Because if it uses it for everything, it's inefficient.
Exactly. And if it doesn't use it for a math problem, it's still inaccurate.
So they had to train it very strategically.
Precisely. They trained it across two major kinds of domains. First, you have the verifiable domains, things like competitive programming problems, math reasoning, where the answers can be checked with code against a ground truth.
Right.
But, and this is crucial, they also trained it on non-verifiable domains, things like dialogue, safety assessments, general helpfulness, where pure textual reasoning and, human preference is really all you have.
So training on both teaches it when to hold back.
Yes, it teaches the value of self-restraint, that sometimes the best move is to just reason in natural language.
And that leads perfectly into the second principle, which is judgment flexibility.
Yeah.
Because in the real world, LLM evaluation isn't just one simple format.
Not at all. And the model has to handle every common setting. You've got the point-wise setting, which is where the judge just assigns a single raw score to one response, maybe on a 1 to 5 scale.
Right.
Then there's pairwise comparison. This is the most common one. It's like the A/B test of the LLM world. The judge just picks its preferred response between two candidates, A or B.
And pairwise is so important because that preference signal is exactly what drives alignment training with methods like RLHF.
It is. And then finally, you have list-wise ranking. That's the most complex. The judge has to order, multiple responses, more than 2 from best to worst.
And the TIR judge architecture can handle all 3.
It's designed to unify its self-verification across all 3 formats, yes.
Now, building a complex, tool-using strategic judge, that just sounds incredibly resource-intensive, which I guess brings us to the third principle, which is about how they avoided having to rely on some giant external model for training data.
That's data efficiency, and they achieve it through iterative reinforcement learning. The whole framework is designed for bootstrapping. It doesn't need to rely heavily on expensive distillation. That's where you copy knowledge from some big proprietary closed-source teacher model. Instead, it improves itself. It generates its own attempts, its own trajectories, evaluates them, and then uses RL to just iteratively refine its own policy.
So instead of paying for a bigger, smarter teacher model, the judge basically learns by doing. It tries something, measures its own accuracy, and just keeps refining its process until it gets it right.
Exactly. It's the ultimate self-directed learning system, but it's tailored specifically for these high-precision tasks.
Okay, this is where the rubber meets the road. This is where you can see the just undeniable superiority of verifiable evidence over just thinking in text. They use this one specific example from the IFEVL benchmark.
Oh, yeah. And this benchmark it was engineered specifically to expose these kinds of text-only flaws.
So what was the prompt?
The prompt was intentionally tricky with multiple precise constraints. It was, write a letter to your friend. In all capital letters, the letter O should appear at least 40 times.
Seems simple enough, but it requires that verifiable counting and formatting.
Right.
So let's walk through the failure of the baseline model, the text-only one. It was Gwyn38B. It sees the prompt, and it just tries to reason its way through counting the letter O in the responses.
And the result was a catastrophe of estimation. It was almost comical, really.
What did it do?
The text judge looked at response A and hallucinated a count of 23 O's. Then it looks at response B and hallucinates 20 O's. So it incorrectly concludes that both of them failed the 40 count requirement. And then, in this final act of just desperate textual reasoning, it chooses the wrong answer anyway. It claimed response B was somehow more aligned, even though its own made-up numbers showed it failed.
That's like the AI version of an essay where all the citations are fake, but the conclusion is delivered with just absolute supreme confidence.
That's a perfect analogy.
Okay, so now contrast that with the TIR Judge 08B.
A completely different world. The TIR judge approached this agentically. Its reasoning trace immediately generated a very specific Python code block.
Not some generic library call.
No, targeted verification code. It wrote little snippets to check the counts, for example, responsi.upper.count-O, and then another simple check for capitalization, something like responsi.upper.
And the output from the Python interpreter, that was the objective truth.
Precisely. The code executed and showed response A actually had 58 O's and response B had 60 O's, so both easily met the 40 count requirement.
Yeah.
But then the code execution also verified the capitalization, and it found that response A passed both constraints, the count and the all caps while response B, despite having tons of O's, failed the capitalization check.
So the TIR judge correctly picked response A based on hard, verifiable data.
While the text-only judge failed on computation, constraint checking, and the final decision all in one go. The tool just eliminates all of those failure modes that are inherent to that kind of soft, non-verifiable reasoning.
It just shows that for instruction following, especially where these constraints are key, you have to have verification.
You cannot rely on estimation. It doesn't matter how powerful the base LLM is.
Now, the success of this whole model really hinges on its intricate reinforcement learning engine, and especially how they engineered the rewards. This judge wasn't just rewarded for being right.
No, it was rewarded for how it got to the right answer. That's the critical difference. They enforced what they call multi-aspect compliance through a three-part reward system. So first, you have the correctness reward, which is binary. You get a 1 if your final judgment matches the ground truth, 0 if it doesn't. Simple enough.
Standard stuff.
Yeah.
Then you have the format reward, $3.
Right. This makes sure the judge's output is structured correctly, putting its final score inside score tags or making sure the code it generates is wrapped properly in Python blocks.
And this is where they added a really clever constraint, right?
Mm-hmm.
Based on that task diversity idea.
Yes. For the non-verifiable tasks, like those safety or general helpfulness judgments, a positive reward is given only if no tools are invoked.
That's fascinating. So it actually forces the model to be mindful of its own efficiency. Was that hard to train, that kind of self-restraint?
It required trials to be very strictly enforced. If the model wastes a tool call on a task where just reasoning would have been fine, it fails the format requirement for that specific attempt.
I see.
And that reinforces the policy to only use the tool when it's absolutely necessary. It saves a ton of computation and processing time.
And the third reward, the tool-specific reward, torals.
Torals is all about efficient and error-free execution. It's only set to 1 if the generated code blocks run without any errors and the judge stays within a very strict call budget. They capped it at a max of 3 code calls per judgment.
So if the code crashes or if the judge gets too chatty and uses 4 calls, it gets 0 credit for $2.
0 credit.
And how do all 3 of these combine for the final reward?
They combine multiplicatively. The final reward totalers is structured, so you only get full credit if you get the correctness, the format, and the tool use all right.
So if you get the right answer but your code crashes, you get penalized.
Heavily penalized. And if you write beautiful, perfect code but you still pick the wrong final answer, you fail the correctness check. It ensures accuracy, efficiency, and protocol are all optimized at the same time.
This careful engineering is what brought them to what might be the most scalable finding of all, TIR Judge 0. This is the model that started from a basic foundation and literally pulled itself up by its own bootstraps using this iterative RL.
Yeah, that's right. TIR Judge 0 iteratively improved by generating its own judgment attempts and then using a process called rejection sampling.
And what's that?
That's where it only accepts and trains on the successful attempts. The ones that produced the correct answer were efficient and had short, high-quality reasoning. It effectively curates its own perfect learning curriculum from its own experience.
And this self-improvement process, it paid off big time. TIR Judge 0 wasn't just comparable to the models that were trained on expensive, distilled data from bigger models.
It actually performed better than them on several key benchmarks. It outperformed on 4 out of 6 point-wise benchmarks and 3 out of 6 pairwise ones.
That's incredible. It proves that you don't necessarily need distillation from these giant proprietary frontier models to build a high-quality specialized judge.
The power of self-verification and this kind of targeted reinforcement learning can yield superior judges, even from relatively small base models.
And when you look at the final performance metrics, the results are just striking. The 8 billion parameter TIR judge consistently blew past strong text-based judges. It achieved accuracy gains of up to 6.4% in the pointwise setting.
And 7.7% in the pairwise setting, that's a huge shift in the quality of preference signals you're getting.
And then there's the parameter efficiency. Consider this. In that really complex list-wise ranking setting, that same 8 billion parameter TIR judge matched 96% of the performance of Claude Opus 4.
That's just enormous leverage from a small, specialized model.
Okay, but here is the most counterintuitive finding for me and why this matters so much for anyone thinking about deployment. They found that incorporating this external code executor added absolutely no extra inference time overhead. In fact, sometimes the TIR judge was more efficient. How is running external code faster than just thinking?
It's a direct consequence of that efficient training policy. Because the RL training penalized long reasoning chains and favored these short, efficient, tool-assisted trajectories through rejection sampling, the final judge learned to be fast.
Yeah.
When it sees a verifiable task, it doesn't waste time on long, verbose, textual calculations. It just quickly writes the code and defers all the hard work to the highly efficient Python interpreter. It's a short thought trace, a fast, verified result.
So what does this all really mean for us? This development of the TIR judge. It's the first end-to-end RL framework that successfully merges that strategic reasoning with external tool use for evaluation.
It makes judgments reliable, verifiable, and, accurate, especially on those really complex instruction-following tasks that so many current LLMs struggle with.
And the relevance for you, the listener, is just immense, because better judges mean better preference signals for future model alignment.
Which translates directly into higher quality, more reliable outputs from the models you use every single day. The judge is the quality controller for the entire next generation of AI.
And if we look even further down the road, this focus on self-improvement through verifiable evidence, which TR Judge Zero demonstrated so well, it suggests a whole new path forward.
It really does.
I mean, if LLM judges can effectively teach themselves how to use tools to verify their own complex reasoning, how quickly might they just completely surpass human capacity in domains that require high precision and verifiable results? Potentially eliminating the need for expensive, human-curated supervision altogether. That shift, it could be happening right now.